So, welcome everyone. Good that you're here. Quick first question: who was here for my last year's talk? Maybe. Okay, no one. That's good. That's good because there will be a slight bit of repetition here. Um, just quickly introducing again to a project because that was already existing last year, and I gave a presentation about the HoneyNet project and stuff that I'm involved in, projects that I do. And now, yeah, I work together with Johannes on improving that project and actually providing some, or implementing quite a cool framework, as I think, and that's what we're going to present on today. So as nobody was there last year, it's not going to be a problem. Okay, so we're talking about hpfriends, real-time social data sharing. And yeah, this whole framework is basically trying to, in a few words, trying to ease or be a simple way for you guys to share data with each other, especially real-time stuff that you have. So that could be messages you just send around, it could be malware, it could be anything that you want, and have that as a very simple to use and configurable framework that feels natural to use. Because yeah, as we're getting into, we thought that everything that was existing and that we were using was kind of a little bit weird to use, was pain to set up or to maintain. All right, so yeah, we'll quickly talk about who's here, who we are, give a good motivation, and then introduce the protocol and the framework, and talk a little bit about the technology we use, because it's kind of funny. We, both Johannes and I, we like to take the new kids on the block in terms of projects, web frameworks, and so on, and try them out. And often, in a lot of cases, that means we need to rewrite everything several times. But yeah, it's definitely fun. Okay, so yeah, I'm Mark, and I'm a not malware researcher only, but security researcher doing mostly malware-related work at Rapid7. And Rapid7, I guess some of you might have seen me yesterday walking around with a Metasploit t-shirt, which is what most people know Rapid7 for. So Rapid7 provides a commercial version of Metasploit, which has additional features compared to the framework that probably a lot of you guys know. Yeah, I've been a member of the HoneyNet project since 2008, which is a non-profit organization based on not a non-profit registered in the US, but based kind of all over the world, with members all over the world, that tries to look into threats, look into malware, look into the latest things that happen that threaten your systems, especially the bad guys, what they're doing in terms of botnets and so on, and try to provide tools that everyone can use as open source, or provide papers or documents that give you guys insights on what is going on, and help you do your job or do interesting research on the side. So yeah, that's pretty much it. We're going into a few more details quickly, but yeah, I'll let Yo-Yo talk a bit.
Yeah, hi, I'm Yo-Yo, or HiPi, some of you may know me. I'm not quite sure. Currently, I'm enrolled in a PhD program at RWTH Aachen University, and I'm doing my PhD at the IT Security Research Group. It's a rather small group, which is why I want to promote it kind of here, because the guys from Bochum had a table and professional material, and I just have these slides. I met Mark and a lot of other cool guys at the research group, and Mark also brought me into the HoneyNet project, which I'm a member of since December last year. Okay, and now we're gonna do a quick slide on what we do at the IT Security Research Group. Yeah, that's the whole research group, including the professor and Hiwis, so rather small. We have a few lectures called IT Security 1 and 2, which are like basic crypto, and then more advanced stuff and practical systems, also soft topics like biometry and so on. We have a lot of mobile security lectures. Mobile means not only like mobile devices, but also mobile network infrastructure security, because the professor is very active in this field. We have our lab, which is every second semester in the summer. It's mandatory for computer science students to take a lab, and they can choose one. And we offer the so-called security lab, which offers like hands-on practical security training, like starting with simple stuff like SQL injections and moving up to some binary exploitation. And the idea is that students who have no practical connection to IT security will finish the lab and know whether they want to work in ITsec or not, hopefully. We also do play in CTF sometimes. In the last few month, not so much anymore, Team Old Europe. It's based on at the research group. And we also managed to organize our own CTFs last year and the year before that. Maybe you heard about it. Okay, I think the next slide is yours.
Yeah. Yeah, so I think, I've spent quite a lot of time during my studying. I actually studied in Aachen as well, and I spent quite a lot of time at this research group, and, the professor and all the guys are pretty cool. And we did some good stuff, some good projects, and especially the lab was a lot of fun, like working with students and, teaching them hacking and, all these techniques. Sometimes they taught me some stuff, of course. I mean, there were pretty clever guys there. So that was quite a lot of fun. And the HoneyNet project has over the last years also, there are actually some guys in the audience as well. You might see some walking around with t-shirts, and it's a pretty cool group, especially for like brainstorming on projects and developing something together or researching into a specific area. Like, a couple of guys, actually Tillman is here today. He did a paper on the Configure virus. Probably a lot of you heard about that. Has been a huge thing. Allegedly millions of infected computers. I think, 1 million was at least confirmed, and still around today. We will see that later on and have some nice attacks from Configure coming in live and just see that it's still there. And yeah, the HoneyNet project is basically doing that and trying to get some sponsoring, and used to be funded by the US government actually to do that kind of research, and provide it as open source and freely to the community, to the security community. So that's pretty cool. If you want to check it out, there's the website. There's a lot of stuff going on. We are active for the fourth year, I think, in the Google Summer of Code. We have like right now, I think 15 or 13, I'm not sure, 15 projects active, and currently students are working on for the HoneyNet project, paid by Google. So that's pretty cool. If anyone, is working in that direction, might as well do it within a HoneyNet project for Google, for example, and get some money out of it. So that's pretty nice. Yeah, so let's get into the actual topic. So the motivation was we are a group of individuals interested in, collecting malware, investigating threats and so on. And we have, in a lot of cases, a lot of data that we either collect from honeypot systems or we get from our, spam folder. Might have attachments to it. And all that stuff kind of is floating around, maybe puts in some databases, but we, if you meet someone at a conference and you talk about that stuff, and then he says, yeah, hey, I have some good data, and if you want to look at it, I can share it with you. And then you have the problem of how are you actually going to do that? Because if you have like a collection of malware, I mean, who is going to send over several gigabytes by email or something? Maybe you're setting up an FTP server, and then, the guy downloads it. What do you do next month? Do you download the whole thing again? Do you do like kind of, monthly uploads? And it's all quite like, custom. So as a little bit of a motivation, we have the scenario here. So for example, Yo-Yo could say, hey, Mark, can I have, hopefully real time, doesn't need to be, but yeah, access to the malware that is hitting your sensor. So for example, I ran some honeypots, which I actually talked about last year. Not going to reintroduce you to that again, but you might find the slides from last year online sometime from SIGINT. And my honeypot systems are capturing attacks all the time, capturing malware. And if someone wants to have access to those, I would like to give them to them in real time. Also, as they're hitting, I don't want them to upload them at the end of the day or at the end of the month and then share them, because this world's moving fast. So it needs to be, fast, and needs to be easy to do that kind of stuff. So other people might say also, hey, Yo-Yo, can you give me access to the samples you get from Mark? So, right, I might share the stuff with him, and he says then to me, hey, I know this great guy, I met him, can I give access to the samples you give me also to him? Can I forward them? And it should not be a matter of him setting up a server and relaying them in some weird way or forwarding emails or something. It should be natural, right? It should be something that we can do easily every day and not get stuck into weird protocols and stuff. Okay, so yeah, what happened, I guess, with other systems that were there before? I mean, there were, for example, web uploads, upload websites, like tools you could set up, or FTP servers where you upload the stuff. So if a new user is introduced to the system, it always ended with, sure, I can share it with you. Let me just get you admin access, or not admin access, but get the admin to give you access, or give you access to the database or whatever, give you credentials. And so it was always kind of a little bit of a complicated process. You had that nice system. For example, in the Honeynet project, actually, we were deploying honeypots globally. You know, lots of countries in the world had honeypots running, and they were connecting and submitting their data to a central database. That was a Postgres SQL server, I think. And so one guy, David Watson, was, you know, giving out access to several people, either as direct Postgres access or just as users to a web interface. And so, you know, someone would say, okay, I want now the data or the malware for the last day. And he only had that web interface. So there was no, you know, there was no real way other than scraping the website or something. It was all very painful. So yeah, this is actually what I, let me refresh that. That looks a bit weird. Can I actually refresh? Holy shit. Okay, yeah, as you see, we try new technologies, and that's what happens. Let me do a new tab here. Can I do that? Why is my, the screen is not, oh shit. Sorry about that. I give some other talks here as well, so. Yeah, I could open the honey map directly, but let's do it this way. I was coding until the last minute, as always. Now, so this is the honey map, which is basically another project that we did together with Yo-Yo as well, and Florian, who is another guy back at the time from the research group, and which was basically just a visualization, just a, you know, one of those fancy world maps that you like to see in media or in screenshots and so on. Always looks fancy, and this thing, I think I should actually go to the honey map directly, so you could also check it out, of course. Makes it a little bit bigger. So this is basically picking up the real-time feed of our honeypots. You might see that there's a lot of stuff going into Aachen, Germany, which is our sensor. It's quite big. The network operating center from the university, you know, gave us, I think, 7,000 public IPs or something. So it's quite, you know, big sensor, and that's why there's a lot of stuff coming in. So not necessarily means that a lot of people are attacking Aachen or something, but yeah, this is basically a live feed, and we wanted to, you know, display all these attacks so that we could get like awareness out there and have a nice picture of what is going on in our sensors and who is submitting data. So you see some, I think, sometimes there are stuff, yeah, there's stuff coming into Mexico. So these are guys from the UNAM University in Mexico City, you know, friends of ours and also active in the Honeynet project. And they run sensors too and submit it to our system. And the thing is, it should be easy for them to actually join the system, right? If I now meet, or there's a new guy coming onto the Honeynet project and they want to set up their honeypot, I don't want them to have a complicated way of setting it up. It should be something they connect, they submit their data somewhere and hit like, give it to Mark. And then it's given to me and I can display it on the map. All right, so that's kind of one of our other motivations. Let me try to find the slides back. Might be somewhere in here. Yeah. All right, so yeah, as I talked about, you have the usual suspects, like you can do batch stuff via FTP, emails. There were people who did rsync at midnight from all their sensor nodes back to a central server. Oh, sorry. And yeah, some people uploaded it to one-click hosters. I mean, there's lots of stuff that you can do. And one of the earliest tries that we did to solve that mess of sharing within the Honeynet project and also with other people was actually XMPP. That was by one friend of ours, Marcus Cutter, who also is one of the honeypot developers in the Honeynet project. Used to be. Anyway, he did basically use the protocol below or behind Jabber, you know, XMPP, the chat protocol that probably most of you use. And he used that protocol and kind of, I don't know, stuck it in this data sharing project where he used XMPP to have a distributed network of sensors sharing with each other. That was quite nice, was quite fine. The problem was he had to modify the XMPP server. And so he did some patches and so on. You couldn't just run it on a normal one. So he had a server running, which worked. Nobody else was able to get a server running, which worked. So, and to get access, you actually had to ask him again to some channels. So in the end, it was quite complicated again. I mean, it was nicer, yes, but it was still quite heavy. Also, I mean, XMPP is not really meant to be, if you, for example, sharing malware, you need to base64 encode it, which blows it up. And yeah, I don't know. I mean, it was not the best. I mean, it was a good protocol to use, but was not designed for it. Okay, HTTP submission was the stuff that we, in most cases, use for honeypots. It's, again, it's nice, it's centralized. So, right. there are no channels. You are not easily, like, you have to build that stuff dedicated for a certain piece of data. I mean, you have like malware samples and you upload zip files of malware samples. So it's all very specific to the type of data. Authentication, access control, all custom, right? Depends on the protocol you use. So it's in most cases, they have some kind of database, user password or something, then you can log in and get data. Okay, all that stuff basically is to motivate you guys. This is not the way to easily share data with each other, which is why we thought we need to have this kind of picture in the end. This was kind of the goal we thought of we need to have. We have this kind of weird cloud in the middle that is, that service which we use to share our data. And we have, for example, where am I? I'm in the bottom left. So I'm in the bottom left. I have my Diania honeypot sensor, and I publish information about attacks and malware binaries. So I have that information. I give it to this cloud, right? And so by default, it just goes into a black hole. Nothing happens. But if anyone is actually interested in that data, he should be able to get it, and that should be fairly easy and fairly simple. So if someone like, let's say Claudio, who was up on stage before, he's also active in the Honeypot project. If he wants to do, analysis on the malware samples, he should just connect to this cloud, to this server, and say, I want to get Mark's data, or I want to basically get data from a specific channel, and then he gets the data and can somehow automatically process it and maybe publish analysis resources again. So this thing, this data or this paradigm, this kind of sharing model is PubSub, like publish subscribe, as most of you might know. And publish subscribe is just this, basically a channel-based way of subscriptions and data producers, data consumers. So it's like IRC. You might know IRC, I guess. So on IRC, you join a channel, you see the messages. If you're not in that channel, you don't get the messages. So it's kind of the same thing, but it's of course not intended for chatting. It's intended for automated data sharing. Okay, so this is what we wanted to have. This actually I presented also a little bit last year, quite quickly, because I also had too many slides, not as many as Claudio, but yeah, quite a lot. And so this is basically this authenticated publish subscribe protocol. I came up with, and it's used by the Honeynet project. It supports like these channels and auth keys, and auth keys are basically a little bit of a security feature. We don't, like, not every sensor that I have has my username and password or my credentials for that service. It has a specific ID and a specific secret that it uses to authenticate. So if anyone compromises my honeypot, he actually doesn't have my account, and he actually doesn't have all the data. He only has that stuff that the honeypot can see, or that system can see. All right, and I had a web interface, I had some channel permissions and so on, and you could basically configure them centrally and give people permissions to certain channels. And in the end, it turned out to be quite a successful project. So we had different languages. It was very simple to use, so different people picked it up and implemented it in, for example, in Go, in Ruby, and there's a JavaScript implementation. There are a lot of languages you can use for actually accessing that stuff. And sadly, it turned out to, quickly, a little bit more info before I go into the problem. So it was pretty simple. You had like publish a message, subscribe to a message, you had an error message type. You had an info thing, which was basically, hey, I'm this server, and it contained a little bit of information for the authentication. And then you had the client sending us authentication information to it. So it was very, very simple design, length, value. It was nothing complicated, but it was perfect for our needs. So yeah, central broker on a server, and we had a small client script, client utility to use that stuff, and also we had modules for all our honeypots. So there is Glasstop, which is a web honeypot by a German guy, and that had support for it. Diania, my stuff had, or Marcus's and my stuff had support for it. Others have too. Actually, there is Cuckoo Sandbox, which is the talk that we do afterwards, after this one, also has a little bit of support for HP feed. So all people kind of started picking this up and started supporting it because it was very, very nice to use. The problem was, though, the central web interface that you needed to use for giving people access to channels was, again, an ACL system. It was an access control list. You had to define who had access to which channels. And at some point, it was like there was some third-party guy who was not a member of the group, and he asked, hey, could I get this data? And I said, yeah, sure, you can get my data. So I asked the Honeynet project, and they said, it's kind of complicated because there's all this other data by these other people in there, and they might not want to share it outside of the Honeynet project. So it's kind of it was really hard to get other people involved because you had all those people on a channel were considered like a closed group, right? They were like a, you know, a sharing group, and you didn't want to introduce third-party guys that they didn't know to it. So it was a little bit of a policy hell for me, at least, because I wanted to just give people my data. I just wanted to have my sensors, my attacks, my malware, wanted to give it out, you know, analyze it. If you have some interesting stuff, give it back. So I just wanted to hand out the data. Other people are more protective. So what actually, if you think about it, what it is it's what we naturally do is we meet people, we get to know them, we like, you know, introduce each other, and if we're interested in the other people's data, then we share it maybe, or, you know, we get it from the other guy. So it's very one-to-one, it's very individual, so it's not really, the same as for, you know, for IRC, where you have a chat channel, which is kind of considered public. You want it to be one-to-one, and it should be natural to represent this stuff inside the system. Okay, so yeah. Actually, I had a slide for this. Good. So yeah, it was very good. It was very easy. A lot of people used it. It was improving steadily. I mean, we always had bugs, right? Everyone has bugs. So they were fixed, and it got better and better. And third parties were interested. We couldn't introduce those third parties because of the problems mentioned. The channels are global, basically. So if you have one certain channel for a specific data type, like diarrhea.capture, which basically was the attack information from my sensors, that was global, right? So anyone who had access could see all the data to it. So it was like on IRC. If you join, you know, dash SIGINT, you would see all the messages there. You wouldn't only see it from a certain subgroup of people. Okay, and yeah, the management of access control, I mean, it didn't necessarily fall only on me. People could give access to others as well, but I had to, you know, do all this stuff again, like if someone else, you know, people basically thought I was the admin, even though they could give access. Everyone came to me and said, hey, yeah, Mark, you run this cool thing, can I get access to this data? And I said, well, it's not really my thing. I mean, those people are sending the data, you should ask them, and they should give you access, right? So it was a little bit unnatural, which is what we need. Is we need a system for this kind of large scale data sharing, should be real time. Yeah, real-time data sharing should be real-time, right? Follow this publish subscribe principles, and it should allow for like distributed natural access control. So you guys should define yourself, who you share with. People should define themselves, what they see. So it should be, yeah, very, very flexible, very easy to use and simple to use. Okay, so yeah, we thought a social kind of model would be the solution, because this is what we do on Facebook or other servers as well. We kind of define people are in which list they are, and what kind of, you know, stuff they see. Maybe they see the party pictures, maybe they don't see these other pictures from that are more private or whatever, or the other way around. So your boss doesn't need to see the party pictures, and all that stuff should be somehow in this system. Okay, so yeah. If you think of, like Yo-Yo said, it's kind of similar to the web of trust and like distributed version control, like JIT. I mean, with JIT, you basically have the repository wherever you want, and you can give it to other people or push to other people, share code, distributed way. All right. So we came up with hpfriends. This is basically an evolution of this data sharing protocol. And the wire format, the actual protocol is identical. So we didn't need to change our sensors. We only changed the central component and the actual, you know, management of it. And this central component now, instead of these access control lists for individual users, it has a graph of users and models kind of the relations between individual users and groups. So yeah, has users and groups, and they are connected by these sharing relations. So for example, if I have data for my Diarrhea attack information and my Kippo SSH honeypot or something, or it might be completely something different, right? I might capture URLs from a proxy or whatever, and I have that information. I decide to share it with Yo-Yo. Then he could also decide to share maybe one certain information of that, if that's okay with me. He could ask me, hey, can I share that maybe to some other guy? And he could pass it on, basically. And he could define, yeah, I want to pass that on. And this information I want to pass to this other guy. So this is what we wanted to have, and this is what we then implemented. So yeah, it operates this social graph. And in this graph, basically users or groups, they are nodes, and the sharing relations, what they want to share is just edges. Very natural. I mean, it felt very, almost, at the time when we thought about it, was almost like, oh yeah, why didn't we think of this before, right? Because it's it fits the problem pretty well. The edges, we decided, needed to have two different types. So there's shares and shares all, which means I share either only my data or everything I see. So if I have stuff from Mark, or if Yo-Yo has stuff from Mark, then he can decide if he only shares his own stuff or everything. Yeah, this is a picture from a software that we actually use. We're going to talk about that a little bit later in the technology part. So yeah, the group membership, it's just a minor detail here. It's also stored. So basically a group is just another user who shares everything with their members. So it's also very natural modeling kind of this problem. Yeah, channels behave quite differently because if you have like a channel like Dioneer.capture, which normally has my attack information from my sensors on it, then separate groups in this graph can use the same channel name without interfering with each other, right? So if I have my sensors and I share data with Yo-Yo, and then some other guys have data and they share it within each other, they don't see our stuff and we don't see their stuff unless there are relations between us. So channels are merely an identifier for data. Like it's merely a tag or a description of the data we want to share. So it's not really it's not becoming part of the authorization or authentication. It's just labeling. Yeah, I can basically sign up to the system, publish data on any channel I want, and I don't disturb anyone. So that's pretty good. I think I can add sharing relationships, so I can say I want to share this with this guy or this with this group of people, and actually, yeah, there was one request. So this third part, like each user can decide whether to accept the share. That came in a little bit later because I thought of the kind of everyone is white hat model. So everyone who signs up to the website and shares data with me, I'll be good to receive it, right? It's cool that they share data with me. And then people said, yeah, but what if they share crap with me? Like, what if they share broken information or some binary blob with me? Like, I don't want that on my channel. So we implemented this accepting of shares. So you need to enable a certain share before it becomes effective. So that means nobody can pollute your data or something. Okay, yeah, demo time. That's pretty much it. We're going to talk about the technology a little bit later after the demo, but pretty much wanted to show you guys what this looks like and how this could go down. Okay, let's see. Where are we? Okay, so this is the web interface. This is this guy. So I have two browsers here because I want to be like two different users and have some a little bit of demo. So this is what it looks like. You log in. Anyone can log in. I can actually do that maybe again here. Hopefully, it lets me in again. So this is the starting website. Explains a little bit of what I just explained. And this is public, right? So you can go there right now, like to hpfriends HoneyCloud.net, which is a very nice hosting service that we provide internally for the HoneyNet project, run by Norwegian guys, awesome guys. So yeah, I run the server there, and you can sign up. Like you can just log in with some accounts because I didn't want to maintain the passwords and password resets and everything. So you just log in with one of your accounts, and I hope this works. Yes, perfect. So you just sign in, and then anyone can do this. It's completely public service. And we can do this now because earlier, right, I told you the third parties, we couldn't let them into our system because we had this, these channels, they were fixed. Everyone could see it once they had access. So now, as everything is separate and based on this graph, anyone can sign up and use it without interfering with us and without seeing our data. And I can share with them without giving them access to anything else. All right, so perfect. So let's see. Okay, this is my account, so there's quite a lot of stuff going on here. But basically here, for example, you can see this is my sharing relations that I define. So I say, for example, I share the channel. I hope it's big enough here. You can read it a little bit. I share, for example, the let's say, whatever, capture here down there. I share Dioneer.capture with the group HoneyNet project. And the group HoneyNet project then has subgroups, or people, or whatever, and they can receive that data if they want it and if they accept that share. There's also other stuff, like I share a channel called random.int with everyone, which is just random integers, right? It's just like a demo channel where you can subscribe to. Okay, yeah, and then I have another account, like another email address, and there I share all I see and my data on this test channel, which is one of the things we want to show right now. So let's see, let's go into this. Maybe a quick more look to the web interface. Yeah, we could do that. So you have another view where you can see what people share with you. So you can see, for example, here, these guys, they share like their near capture stuff with me. I didn't enable it yet because, I mean, lots of people start to share stuff with me. So Max also shares stuff with me. He was sitting somewhere here. And yeah, so for example, here, you can see that Christian L, so this guy here, shares Dione Capture with the HoneyNet project, and I enabled it. Which means essentially, because this is my account, and I also run this honey map, that his stuff, even though I think this guy is actually not HoneyNet project, even his stuff pops up on the honey map. Because my, my account and the honey map basically runs on my account, and I accepted his data. So he gives data to me. I don't even know where he runs his sensor. I just say, okay, this is a cool guy. I met him or I talked to him. He wants to share data with me, and he asked if he could, if I could display his dots on the honey map. The only thing that happened was he configured his stuff for hpfriends or for hpfeeds basically, and said, okay, share this channel with Mark. I click accept, and it pops up on a honey map. So it's really natural because everything's hooked up, right? Okay, so that's pretty cool. Let's go quickly. So auth keys. Oh, this is recorded, right? Oh, shit. Yeah, these are my identifiers in secret. But basically, let's do this other account. That's not so prominent. Okay, yeah, might need to change those secrets. Okay, so basically, as I told you guys, every source or sink in this graph, in this system, is identified by, it has an identifier, its own identifier, and a secret. And this is because of the, basically a compromise mitigation reason. If anyone compromises my honeypot, or it's a shared system and they know this stuff, I don't want them to know my actual account and password. I want them to just know the stuff that is, used for this specific sensor. So here in this case, this is like an identifier that I use. It's just a comment test via, yeah. It can subscribe. So this in the right here says this specific auth key can subscribe to these channels, and it cannot actually publish anywhere. So that means if this is running on like some shell, some box somewhere, and it gets compromised, those people can actually only subscribe then with that information, with that credential. They can only subscribe to this, and they cannot publish anything, right? So they don't get like my full access basically. All right, so there's some logging stuff, the groups, we can look at the groups, and there's a global search, so that's not really that important. So let's try to see if we can subscribe somewhere and see some data. Okay, I need to make this probably a little bit bigger. Okay, let's see. Random int, I had the random int thing here. This is test channel, right? This is test channel. Let me quickly go to the random int channel. Okay, so random int channel is like a, yeah, as I said, it's just a channel that I have an auth key on that just runs and sends that random integer. So the first thing you could do is, once you have the tools, or whether you use Go or Ruby or Python or whatever, there's a library available. And when you use that, so this is the Python command line thing that I wrote, and that is, it's available on GitHub, of course. And you could just use it and try, like you sign up for the hpfriends website, you generate an auth key, you make it able to subscribe to random int, and then you can try if it works, right? And you should see my stuff because I share this channel with everyone in the system. So yeah, it's just a quick way to demonstrate that it actually works. And then we can go into like other stuff, like for example, what did I prepare? Where are we? That was test channel. Okay, so here, again, sorry, I should have probably explained the command line a bit, but it's just standard stuff. Like I start the client, host, port, identifier, secret, and then a channel and subscribe. I mean, it's nothing fancy, right? Okay, so I'm subscribed to this. There's nothing coming on this channel. There's nothing coming in. Now this is actually, if we look at this, this is actually WKTY something. So this is actually from my second account. Let me show you. So this is this one, right? This is this auth key. Now it's a bit confusing because both accounts are named after my name, so it's a little bit mixed up. But basically, two different accounts. And they have a sharing relationship with each other. I can show you that quickly. So here, this is the guy. He's subscribed to test gen 1. He can subscribe there. And let's look at the share with you thing. And there you see. So this is my Google Mail account, and there's this other account which is called after my nickname. So this is rep. And rep shares test channel 1. Perfect. Test channel 1 shares it with me. And I enabled it. So I should be able to see data that this other account, the other me, the other personality of me, yeah, sends. We should have probably done this with Yo-Yo, but we asked for dual screens, but it's apparently a little bit complicated and messes up the streaming. So, okay, let's do this. Let's publish something here. I prepared a small script in the top right here. It's just a script that I think sends random numbers again. just like to do that stuff. So yeah, I should, if I publish this, see on the left side something coming in, and sure I do. So we see here random from Mark, right? So this is what this second user, it's actually me, but it's a second user, some other guy, receives now from me. And I send him basically a string, random from Mark, and this number. This data, by the way, I didn't tell you that because it's kind of the introduction to HP feeds normally. I had that, didn't have that in the slides. It supports arbitrary data. So you define what you send. It doesn't need to be JSON, doesn't need to be, huh?
It is in the slides later.
It is on the slides later on in the technology part, sorry. Okay. Yeah, let's skip that. Okay, now at this point, we could try that you send something on that channel.
Yeah, random int, I think.
Not random int. This is test channel 1.
Yeah, okay, then I have to share.
Yeah, so we give Yo-Yo a quick second to change his parameters. But basically what should happen is so who's sending? This guy is sending right now. So shared, what?
Which account?
Just with me with rep. So this account has configured shares all relationship. So I'm sending everything that I see and I myself send on test channel 1 to this other me. And so right now I'm only seeing this guy's only seeing my messages. If Yo-Yo sends some messages to me, it should also like travel, right? It should pop up on this same command line because I have a share all relationship here. So hopefully this works and hopefully this is not too confusing. Okay. Did you share that stuff with me already? Shared with you. Where are you, guy? Yo-Yo, HiPi, test Chen 1. Here you can see it's a little bit hard to read. I hope it works. Let's scroll down a bit. Yeah, so he shares that stuff with me, and I enable it. So, oh no, that's not good. What the hell? Shared with you. Test Gen 1. Ah, okay. Refresh. All right. Refreshed, and now I enable this this sharing relation basically. And let's see what happens. Can you publish something on it, John? Like oh, perfect. So Yo-Yo from another auth key of his sent hello SIGINT crowd from Yo-Yo. He sent that to my first me, right? But this guy also shares everything he sees with the second one, so it passes through. So which means, you know, if for example, now I have my sensors running, and I share that information, let's say, with Tillman, and Tillman meets one of you guys at a conference, and you want to, you know, you exchange information, and he says, yeah, I could give you the data, and we have quite a lot of stuff. We have a sensor in Aachen. It's not run by me, but it's run by Mark. And I can ask him if you can have the data. So I say yes, and he configures everything with you. I don't even know you, and still my data travels through because I trust him. I give him my data, and he asked me, yeah, it's okay, I can share it, so it's fine. So it's kind of a very, I hope, I think it is. Hope it's not too confusing, but basically I think this is very natural in terms of sharing data. This is just, publish, subscribe, like an IRC chat, but everyone defines which messages travel where and if they're relayed and if, how this whole thing looks and how this whole thing works. Okay, we're almost out of time. Let's go a little bit into the slides for the actual, where are we? Here are we. I should have closed this stuff. Yeah. Okay, so the implementation, quickly a word about this. So this is a bit embarrassing. So I started with this stuff and thought, okay, graph, we wanted to have the graph, and I heard about this new fancy Java database, which is called Neo4j. It's kind of a new kid on the block. I'm not sure if anyone heard about this. Neo4j, okay, some people, 3, 4, okay. Yeah, it's basically a graph database. So the native objects in that database are nodes and relationships. So it's kind of perfect. I mean, it sounded perfect to me. And you can do stuff like, hey, tell me whether there's a connection from this one to, you know, this other guy somewhere there and along these relations. So I think it's very natural for the stuff that I want to do. Sadly, I hope that maybe some of you guys can like update me on this, but sadly I had a lot of problems with it, and I still think we have some problems still in there. I mean, it works. We use the system quite well. A lot of people are on there. It's okay, but it's really a little bit unstable. So I had, for example, the problem that I sent queries to the database and the exact same thing with the script. I mean, I didn't change anything. And 2 times after the other, it would give me different results, like different paths, or it would give me either no path or yes, there is a path. So it's a little bit unstable. Then I had to implement like try a few times because sometimes the responses are empty. And so I needed to, ask it again and ask it again. I don't know. I mean, it's really quite cool. I mean, I could actually show you the web interface if we have like a minute left at the end.
We still have the query. So next.
Yeah, right. But I could show that a little bit more. But I think it's a cool project. I maybe have adopted it too early, but yeah, it's quite nice. So I thought about actually replacing it and doing something different to actually model that stuff. This is not too performant sometimes, so depending on how you model it and how your query is, can take a little bit of time, response time. So the actual query might take from, I mean, depends on whether you did it already. They have some caching in there, but between, let's say, 1/10 of a second and 1.5 seconds or something. So if you think about it, you send a message to the system and it takes 1.5 seconds to do the lookup. There are like thousands of messages per second and so on. It's quite of a problem for this database, at least. I mean, it uses like an HTTP API, and it's not really very efficient. So I implemented caching. So basically every result is cached for a few minutes, I think 5 minutes. I reduced it a little bit, but basically once the system sees, okay, this message from this guy cannot travel to this guy, then it keeps track of that answer and keeps it for some time. So we had to implement that, and it's still not perfectly stable. So once in a while, I right now have to Control-C the whole thing, and but yeah, it's okay. All right, so this is what a query looks like to this thing, which is actually quite nice, I think. So you have this start command or part of the query. So we start out with 2 nodes, uSource and uDest. So user source and user destination, and based on their IDs. So a user has an ID in the system, and we just use that to look it up in Neo. Then we do a match on a path between user source and user destination, minimum length 1. I mean, that's sure. And also we want to have another path that says, this is actually a little bit missing. So I removed this umid part. So I removed this one because the query is a little bit more complicated than this in for real. But basically we want to see if the guy at the end, the receiver, actually accepts that sharing relation. This is basically the right part. Like when he accepts it, it should be returned. If he doesn't accept it, it should not be returned. This is why we have that part in there. And the other with statement there says, it does just define some local variables basically, and the ID of the last one needs to be, okay, so which just matches basically the last part in that path to the user ID that is in the second path. So the first path needs to be, the node that you accept from basically needs to be the same in both paths. Okay, sounds a bit weird, but it's basically just saying, hey, I have this source, I have this destination, do they share with each other, and does the second guy actually accept this? So for real, it looks a bit more complicated because we want to match the channel name and we want to decide between shares and shares all. But generally, this is how it looks like. It's quite easy. Okay. The front end, maybe Yo-Yo real quick, back again.
Yeah, maybe I can say a few more words. The front end was done, you can view it online on the hpfriends website. Front end was done in Meteor.js, and that was also not my decision to use. But in the end, I had to go along with it and try to make it work. It's a real-time JavaScript and Node.js framework, so it's client-server combined framework, and it packs a lot of features into it, even more than you could imagine you would need for a web interface. So these are just a few buzzwords. The point I'm making is that if you ever want to get up to speed on the current state of web development, just check out this one single framework and all the stuff that it does, and ask yourself what happened to the last time you wrote a simple PHP script. Anyway, it enabled us to do a few cool things. So the whole interface is real-time, meaning if I add a share relationship with Mark, it will pop up immediately on Mark's side. It is latency compensation, which means, for example, that if I try to perform an action, which I'm not allowed to, the action will be performed on my client, so it will look like a desktop app because it's responsive. But when the response from the server gets back, okay, he's not allowed to do that, the interface will be patched up again. The point is that you can really use these web UIs like desktop UIs nowadays.
We could try a quick demo, but
yeah, okay.
Okay.
And all the other Web 2.0 stuff. So if you're into that stuff, check it out. If JavaScript already makes you cringe, then stay away from it.
Okay, do we have any more things? Oh yeah, this is the hpfriends wire format. I'm not going to get into that, but it's basically really simple. Like we have a message length and the actual opcode, and then you see in the bottom here, this is actually a, what is it? It's a publish message. And so this says the message is, 85 bytes long. The opcode is 3, which is publish. The next thing that I'm sending is 9 bytes long, which is the identifier of the channel. And then I'm sending a 9 bytes, no, wait, this is the identifier that I'm sending from, so the auth key. Then there's the channel, and then there's the payload. So it's a very simple like wire format and easy to use. But you could check it out on the repository. Yeah, this stuff supports it. There's a thug, low interaction honey client, which analyzes websites, analyzes URLs for exploits and so on, malicious stuff. There's Dioneer, which is the server honeypot I worked on. There's Kippo, which is an SSH honeypot that you might know. There's other software that can use it and interfaces with it, and anybody, of course, is welcome to use it. Yeah, here are the links, more for reference. Florian did a Go and Ruby implementations. Yeah, and basically, thank you. If you guys want to see anything more of that, maybe let's do it afterwards, because I think we have 2 minutes or 1 minute left. All right. Yeah, I mean, if there are any questions, do them now. Maybe I can get one response if any one of you thinks this makes sense, or kind of you agree or something. Okay, I see some nodding, but nobody really wants to step up. Yeah. I think it makes sense, and I really enjoy using it, and so hopefully we'll make it even better and more stable and get rid of some of the kick-ass new San Francisco stuff that we used. All right, yeah, follow us on Twitter.